Okay, one of the sheets that I gave out the last day you were in class was this displacement and velocity versus time graphs, a summary sheet. It kind of compares and contrasts them. And I thought it might help you to keep things straight in your head or to get them straight. So like if you're looking for displacement on a displacement versus time graph, you just read it off the y-axis. Whereas if you're looking for displacement on a velocity versus time graph, you have to find the area under the curve and include the direction. If you're looking for the distance on a displacement versus time graph, you read off the read it off the y-axis, but then add all the sections together, ignoring the direction. If you're doing it on a velocity versus time graph, it's the area under the curve again, where you add up all the pieces, ignoring the direction. So for velocity, you add up all the pieces, but including positives and negatives for east-west. But for distance, you don't keep the positives and negatives, you just add up the pieces. If you want instantaneous velocity or velocity at 3 seconds or 8 seconds, then you're going to find the slope of the line. Okay? And if you want the speed, so this one is slope of the line with the direction. This one is slope of the line, but ignore the direction. So on a displacement versus time graph, what we call the instantaneous velocity or the instantaneous speed. Find the velocity at 13 seconds. Slope of the line. If it's not linear, you would draw a tangent, but yours will always be linear. That's why I'm not even mentioning the second part. If you want to find the instantaneous speed or velocity on a velocity versus time graph, you just read it off the y-axis. Like you go 8 seconds, you go up to the line, you go across, you read it off the y-axis, and you include the direction. If it's displacement, you ignore the direction. You ignore the east-west or north-south, positive, negative, if it's distance. Okay, average velocity. For displacement versus time graph, it's going to be this second piece. It says, first piece says draw a straight line to connect the 2 points and then take the slope. That's if they're like non-linear, like looking for one that I just did over here. Like here, if I'd asked you to find the average velocity in the first 6 seconds, you could have made a fake line here. Whoops, imagine it went there, and found the slope. But usually what we do instead is we take the displacement, which is negative 20 meters per second, and we divide by the time. Okay, so it's in the chart, it's really this second part. Whoops, right here. Find the displacement of over that period of time from the y-axis and divide by the time. If you want to find average velocity on a velocity versus time graph, it's the same equation. It's just that this time to get the displacement, you have to find the area under. Okay, to find the average speed, again it's delta d over delta t, but this time it's distance, not displacement. And over here, again, it's distance, not displacement. In the velocity versus time graph, you'll find it by getting the area underneath. Instantaneous acceleration and average acceleration on a displacement versus time graph, you cannot find them. On a velocity versus time graph, the slope. Okay, so to find the acceleration at 3 seconds, at 10 seconds, you find the slope. If it asks you for the average, like one question up here did, what one was it? Anyway, it was the one that wanted the average acceleration in the first 12 seconds. What you would do would be find the slope of the line connecting those 2 points. I promise I will not ask you one like that. How do you find out if it's stopped on a displacement versus time graph? A horizontal line. On a velocity versus time graph, whenever it goes across the x-axis. So here, it was speeding up to 6 meters. This is the velocity versus time graph. Speeding up to 6 meters per second east, then slowing down until it stops, changes direction, constant velocity. So whenever it crosses or runs along the x-axis in a velocity versus time graph, it has stopped. How do you tell change in direction? In a displacement versus time graph, positive slope is one way, negative slope is the other. So whenever the slope, it changes direction, the slope will be in the opposite direction. On a velocity versus time graph, it changes from above, oops, wrong side, above the axis to below the axis, x-axis. So here it's east, here it's west, here it's back east again. So it changes direction every time it crosses the x-axis. And how can you tell if it returns to the origin? On a displacement versus time graph, it's whenever it comes back to the x-axis. On a velocity versus time graph, it's whenever the area above the axis equals the area below the axis. Okay, so hopefully this will help you as you continue to do some of these. So I also gave you three other sheets. This is the one I want you to work on next, the one that's displacement versus time in a north-south direction. Okay, I was going to do a video of it and for the answers, but I think I'd rather go over it when you're back in class in person, and that way if there's still things screwing you up, we can fix it. Okay, so do both sides, the displacement versus time and the velocity versus time, and we will go over it when I see you again. I also gave you a fourth graph. It's the one that says assignment. Guess why? It's an assignment. So I won't make you hand this in the next day I see you. I'll let you hand it in the following day. Okay? And that way you can work on it now, but I'll let you have one more overnight with it after we go over this guy, just in case things still aren't quite straight. Okay? So if you're feeling really confident, you can do it, but hold on to it until after we go over the north-south fella before you hand it in. The other sheet I gave you was a linear motion and kinematics review for the test. So the test is going to be the end of the coming week. I tried to put example questions that we're trying to hit all the different things we did. So the first few were like dot diagrams. Number 3 is like the Alex, Jennifer, Darcy one, different people moving at different speeds. The next couple are about vectors, next 3 or so, maybe 4. And then numbers 8, 9, 10, 11, 12, 13, 14, 15 are using the two equations VAV equals delta D over delta T and A equals VF minus VI over delta T to just give you some more practice, okay? And you're going to write down the formula, write down your givens, rearrange it, and I put the answers here so you'll know if you got them right. Number 15 and 16 are relative velocity, so little practice for those. And 17, 18, 19 are on graphs. Now, do you need to do all this for the next day I see you? Nope. This is a review for you to get you ready for the test. So you can work on it whenever you have time. For the most part, I put the answers in. I think the only one the answer isn't there for is number 1 because it required me drawing dots. Okay, but I think I put the answers for all the others. I will ask the next time I see you if you had any questions on it, but I'm also in my room every day at lunch. So if you're working on this before the test and things don't make sense, feel free to come in and ask me. Now, when I see you again, after we go over the north-south graph, because this one that I'm asking you to do next, the graph number 3 or number C, is north-south. After we go over that, I will talk to you for a few minutes about what the test will look like, okay? There's going to be one more video today where I'm going to show you 2 new equations, but those 2 new equations will not be on the next test. They'll be on the test after. Okay, so I'd like you to watch the video so you can see the equations, and that way after we finish doing this the next day in class and talking about the test, I can do a few examples with you of those new equations, okay? But they won't be on the test this week. They'll be on the one that'll be in a couple of weeks' time. So do not panic about them, okay? All right, so this is what you're going to have done for the next time I see you. You're going to be working on this, and depending on how much time you have this weekend, this week, you know, get as much, it's for you to help you with the test. And this one you're going to hand in not the next day I see you, but the day after that, okay? One more video to come.